Hello and welcome. Today we're going to go over the basics on using Altium and how to actually get a project started on here. So first things first, we're going to go to File, create a new project, and we're going to create one in the MASA-Dearborn workspace, which you have access to if you've been added to the Altium 365 workspace. So right here we have a few options. We can create a 4-layer template, and by the time all of you are using it, there will also be a 2 and 6-layer template. There's the default project, which we don't really want to use, as well as the empty project. And then likewise, there is this assembly template and default and empty. Again, we don't want to use the default or empty, but rather the assembly project. We're going to start by showing how to make a regular PCB project, since that's what most people will be working with. Since we only have to make one assembly project per project here, which I'll talk about when we get to it. But real quick, we're just going to create an example project, and you can add a script if you want. You need to make sure that the formal version control is enabled, since that's how we ensure that we can actually use the project with multiple collaborators, and that we have a project history in case we screw anything up. So if we set that up, we can hit create, and then it'll give us a second to create the project. And this is supposed to be a hierarchical project. However, Altium has a slight issue with it for some reason, where when you create the project, it does not show up like that by default. So you just have to close the project and go to Open Project and go to the MASA-Dearborn workspace and reopen it, and you'll see that there is the proper schematic hierarchy this time. So if we go over here real quick, you can see that we've got each schematic has some child schematics, which we'll talk about in a minute. So real quick, we're going to go ahead and not open. We're going to create a multi-board assembly project now. So as I said earlier, we only have to make one of these per project here. That's just because all of these individual schematic or individual projects get added to it, and this is just used in order to kind of collect all of them so that we can easily pull all the projects at once, as well as to collect information for our bills of materials and other things like that. So we'll create a multi-board example project real quick. So we'll just say multi-board, and we will create that. And this creates a product very similar to before. The big difference is that there are some different files in here. So if we want to add in this example project we made earlier into this multi-board project, we can just go over here and we can create a new box. If we double click on it, we can open the properties and hit source, and we can go to the MASA-Dearborn workspace and add that example project to our higher level multi-board project. And we can save this. And last thing we can do is we can go to Show Differences, Advanced Mode, and we'll leave one side on this MBS doc, and we'll put the other one on this MBA doc. And what's going to happen is we're going to update the MBA doc to include this new project in it. And if we create engineering change order and we execute it, so now if we go over to this MBA doc, you'll see that the PCB, which we have over here, is now in this project, which is nice for being able to visualize what's going on, and it's important because this is actually where our bill of materials pulls this information from. So we can do that real quick. Additionally, once we've actually finished modifying the project, we can hit Save to Server, and we can add a little account to say what our changes were, and I can just say added video example, and now all those local changes that we just made have been saved onto the server with that nice little message so that we can see how things were changed and when, and we can easily revert changes and also collaborate on the changes. So now if we come over to our example project over here, we can talk a little more about the hierarchical schematics. So on here, we have these nice green boxes which represent sub-schematics. So if we click on this is the power schematic, we can right click, go to Sheet Civil Actions, and we can open the sub-sheet, which will open up it would work, Sheet Civil Actions, open sub-sheet power, there you go, which opens up this power schematic. You can also just traverse it over on this sidebar. And you see that we can embed multiple hierarchical products inside of each other. If you want to create a new hierarchical sheet, you can come up here to this place sheet symbol. we can make a new sheet, and we can, so two things you can do. You can right click on your project and you can add new to the project. We can add a new schematic, and then we just go over here to the properties, and we would, like earlier, set the schematic to with this, or we can right click and we can actually go to sheet selections and we can create a new sheet from the symbol. So if we do that, it creates this, and we can just Control S to save it, and we can just say example sheet, and it will save that. And if we go back over here, it will ask us to link it. So if we just go over here, we can hit OK, and now this is a hierarchical setup. So with these hierarchical setups, the main important thing that we can do with them for connecting things up properly is we can add ports. So if I go into this example sheet real quick, I can go over here to components, and we're going to not do all, but we're specifically going to open that up. We're going to go to MASA, and in my case more specifically, I'm going to go over to the SMD elements, and I'm just going to place down a resistor. And what we can do is we can add in some ports. So if I go over here, you have the place port right here, so you just do that, and if you hit space you can reorient everything. And I'm just going to add a port onto one side of that, and we can double click on it to open up the properties. We can give it a name. I'm just going to call this just output resistor, nothing special, but that's what you'd expect when we don't actually have a reason for this port existing. And you also need to set the IO type. In this case, I'll set the IO type as bidirectional. It'll depend on what you're doing, but once you do that, that's all you have to do with the ports. And then I'm also going to go over here and I'm going to create a power port. In this case, I'm going to create a ground power port. So what that does is it connects us to the ground port. If we go here, power plus CAN, you'll see that this ground is also connected up to this pin on this connector. And these ground ports, even though we didn't connect them on a higher level sheet like this video example, they still connect logically on the schematic. So these power ports are global between different sheets. So if we do that, and we can go over here and hit save all, what we can do is we can come back up here, we can click on this, we can right click, we can go to sheet symbol actions, and we can synchronize entries and ports, and we can add that sheet entry, and then just click there, hit close, and now we've got this nice little connection which is connecting to the resistor down here. And real quick, I'm actually going to change this to being an input instead of bidirectional. And what we can do up here is, let's say I wanted to connect it to something else, say an LED over here. I can do that, and then I just grab our regular old wire tool, just click on that, and I just connect those together, and then I can create another power port. And if we check over here on the power plus CAN, we've got this VBAP port, which is what I'm going to use for this, which you probably won't use very often, but it's just an example. And real quick on here, since I changed the output type, I'm going to change this to being an input, since we are inputting from here. And if I do that, then we can save all of this again. Now, one last thing to talk about on the schematic side is if we go to panels, you can open up the properties menu, which you can also see on this bar over here. The main thing here is you can change your sheet size. There's not a whole lot else you usually want to mess with, but it's just important to remember since it's in a little bit of a weird place that a lot of people forget about. So it's just good to remember that. So now that we have our stuff set up, we can right click and show differences. Well, actually, before we even do that, I'm going to go over here and we're going to perform annotation. All this is, and I'm just going to do this, hit update change list, hit OK, and accept the change list. And all this is going to do is it's going to give annotations to those new components that I added. So you'll see that earlier our LED was called LED question mark. Now it's LED 1. So this just adds designators to our components so we can identify them more easily. And now once I've done that, I can right click, hit show differences, and I can just click on the PCB document, hit OK. I'll tell it to automatically create the links. And usually you just want to right click, hit update all in the PCB, create a change order, and execute, and it's going to add in all those new components. So the couple of important things here. One is that every sheet that we have gets what's called a component room. So you can see that this is the connector from the Power Plus CAN schematic. This is the LED from that top level schematic, and this is the resistor from the other one. And in fact, something that we forgot to do that I'm going to go back and change right now is we didn't actually rename this. This is just called file name, which is no good. We're just going to rename it to example sheet. If you have multiple schematics with the same name, then Altium gets mad and doesn't compile properly, so you want to make sure that you name those, unlike me. So if we do that, we can just right click and update it again. It's just going to change the room name pretty much, and you'll see that now example sheet, for some reason it moved over here, but we can select this component and then drag it over. Also, if you want to zoom in and out, you just hold Control and use your mouse wheel to scroll. If you want to pan back and forth, you just hold the right mouse button and you can pan back and forth. So now that we've done that, we're going to move our example sheet over here. I'm going to make this a lot smaller. And as you can see, there's these little air wires, which just tells us where everything wants to connect to. So real quick, this is a little bit of an awkward step, so I'm just going to rotate this so that things are a little bit easier to work with. And now we can connect these up. So if we go over here to the interactive routing tool, I can select this pad and I can route over here. So this is everything by default, but let's say that my trace is a little bit too thin. I can hit tab and we can come over here, we can alter the trace width as well as the default via sizes. In our case, I'm going to change my width. As you can see, there is the min, max, and preferred. I'll change it to the preferred, which is the smallest one, but that's a little bit too small, so I'm actually going to up the width to, say, like 0.5 millimeter. And you just run your mouse over here, and you can click on it to connect them. You can also move traces that you've made just by clicking and holding. So once that's been done, we can also come over and connect these up. So let's say, for example, that there was something in the way of this connection. What we could do is we could hit star on the keyboard and we can actually create a via. This via is a little bit too big since I changed what my stuff was set to. So I'm just going to change it to a 1 millimeter, well, I'll change it to 0.5 millimeter and 0.2 millimeter. Your default should be much more reasonable than that. I changed mine since I was working this earlier, but it should all be nice and set for everyone else. And you just click and it will take you down to the bottom layer so you don't interrupt your routing session. In this case, I actually need to be on the top layer, so I'm actually going to hit star again, and we're going to place down our via that puts us back on the top layer, and then connect up to that pad. And now there's just these last two pads to connect, and I can just connect them very simply like we did earlier. And this is a terrible looking routing job that I would never accept, but it's good enough to show the example of how you use the tools. So that should cover just about everything. Once you've finished changing everything, like before, you can just hit save to server, and I can just say showed Altium overview, and then you just hit OK, and everything gets committed to the server like before.